Hello everyone, so today's lesson is on rates of change and tangent lines. So our objective, our goal for today is to use the limit definition of derivative to find the slope of a tangent line to a curve. Okay, so slope of a line, or find the slope of a line tangent. So we're finding the slope of a line, and you already know how to find the slope of a line. So opening question, what is the slope of the secant line to the function f of x equals 2x squared plus 3 that passes through the point 1, 5, and 3, comma 21? So at first you might read this and you're like, I don't know. Just realize it's whoa, gotta calm that down. It is a upward facing parabola, right? I know that because it's 2x squared, right? And then it's telling me that there's 2 points on the parabola, 1, 5, and 3, 21, and it wants me to find the slope of this line. So really, it doesn't even matter that it's touching the parabola, that it's secant to the parabola. Okay, so to find the slope of that line, we just use the slope formula. Remember, slope formula is y2 minus y1 over x2 minus x1. So then we have 16 over 2. So the slope of the secant line is 8. Okay? All right, so slopes of secant lines are called average rates of change, and that's because we're using 2 points. So when you're using 2 points, that's average rate of change. This next part here, we've actually done this math before, first semester, when we did it in our chapter 1 test, if you recall. So it says, what's the slope of the secant line that passes through? And then I'm going to give you your first point is x comma f of x, and your second point is x plus h comma f of x plus h. So if we use the slope formula, we have f of x plus h minus, because this is x1, y1, x2, y2. So I'm just using the slope formula. So y2 minus y1, f of x, over x2 minus x1, x plus h minus x1, which is just x. So then I asked you guys when we learned this the first time, is there any way I can clean this up? I can do x minus x. So what we end up with is f of x plus h minus f of x all over h. And we have learned this formula before. Do you remember what this formula is called? I'll give you a clue. It uses this, it has this in it and this in the name. It is the difference quotient. All right, so my next question to you is, how can we make a secant line become a tangent line? Okay, so to have you think about this here, I'm going to use the idea that if I have those 2 points, where this first point is x comma f of x, and this second point is x plus h comma f of x plus h, just like you were given. So what does that mean? That means that this point is over x, and then this point is over x, which is this much, and then over h more, right? So this is x plus h right here. Also realize this distance right here is h. Okay, so really what the question that I'm asking you is how do I get these 2 points to become 1 point? Okay, so if you think about it, in order to do that, let me see if I can get my scissors out here and grab that. No, that's not what I wanted to do. Oh, because it froze. My Notability froze. We're no stranger to that. Okay, so back to what I was trying to do. I'm going to take this. So basically, I would get this closer and 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 closer here to becomes 1 point. So if you think about what I'm doing right there is I'm making this closer and closer and closer. What am I doing to h? I'm making h smaller and smaller and smaller and smaller and smaller. In other words, I'm making h approach 0. Now, when you hear that word approach, you should be thinking limits, okay? So how can we make the secant line become a tangent line? We can take the limit as h approaches 0. Okay, so when all said and done, the slope of f at x is given by the limit as h approaches 0 of the difference quotient. So f of x plus h minus f of x all over h. So this is our very important formula for the day here. This formula, like in our goal, is called the limit definition of derivative. Okay, so this is what I just put this cloud around. That's the limit definition of the derivative. So what you're going to see, like when we get to these problems here, it says use the limit definition of derivative to find the slope. So they want you, or we want you, to use this formula here. Okay. Now, slopes of tangent lines, these are called instantaneous. I always cannot spell this. Yes. I'm sure people are laughing as I do that. Rates of change. Okay, so this is instantaneous since there's 1 point. Average would be 2 points. Okay, so now we have the rest of this is just examples here. So all of this is just practice doing this. Okay, now I always try to not start with the first one because I feel like I lose people. Not lose people, it's just that it's oversimplified. So we're going to start with problem number 2. We'll go back to number 1. Okay, so it says use the limit definition of the derivative to find the slope. Limited definition of the derivative to find the slope is the same thing finding the instantaneous rate of change. Also, the derivative of f of x is notated as f prime of x. Okay, so that's how you write derivative. Okay, so let's start with number 2. Okay, we're using the limit definition of the derivative to find the derivative. So first off, the derivative is g prime of x. And that's equal to the limit as h approaches 0 of, so now I need to find f of x plus h. Okay, so remember, if I want to find f of x plus h, I'm going to plug in x plus h into these 2 spots for x. Okay, so I will color code this just to make it make more sense. I'm going to do f of x plus h in red. Okay. All right, so that's 3 times, and then instead of writing x right here, I'm going to write x plus h quantity squared, plus 3 times, instead of writing x right here, I'm going to write x plus h, and then plus 3. That's f of x plus h. Now I need to subtract from this. I'm going to go back to pink here because that's part of the formula. Subtract from this f of x. Now, what's really important is that you realize that this is one whole function that I'm going to have to simplify. And then also we're going to subtract f of x. Okay? Remember doing this? Or sorry, g of x for this one. It's not called f of x. All right, so now I just need g of x, which is this right here. All right, so g of x or f of x or whatever it is, at the point I'll color code that and put that in green. Okay. All right, so that's 3x squared plus 3x plus 3. And then it's divided by h. So I'm going to switch back to pink here, divided by h. Okay, so now I have to clean this up. Now, while cleaning this up, remember, you cannot get rid of the limit as h approaches 0 until you can actually plug in 0 for h. So can I plug in 0 for h right now and get an answer? No, because I'll get undefined because it's in the denominator. So what I'm going to have to do is I'm going to have to use the cancellation technique, but I'll have to expand this in order to do that. Okay, so let's start off by expanding x plus h quantity squared. So remember, x plus h quantity squared, I'll write it off to the side. X plus h quantity squared is the same thing as x plus h times x plus h, which is equal to x squared plus 2xh plus h squared. So I just have this memorized so that I don't have to do that because you'll see it a lot. Okay, so I have 3 times the quantity of x squared plus 2xh plus h squared plus, and I'm going to distribute this 3 here, 3x plus 3h, and then I have that plus 3. And now, very important, I have to remember to distribute this negative. So this negative has to go to all 3 of these. I have to subtract all 3. So what I like to do is change it to addition, and then just change the sign of everything in the parentheses. So that is minus 3x squared minus 3x minus 3, and then that's all over h. All right, next I have to distribute this 3 here to these 3 things. So what I'm going to do is I'm going to do it right above that, that work there, so I don't have to make an extra step. So distributing the 3, I get 3x squared plus 6xh plus 3h squared. So this is now gone. Okay, now I'm going to clean this up. So you're looking for things that cancel out. Now if you do this correctly, everything in blue should cancel out here. Everything that was part of f of x. Everything that was in this parentheses here. Okay, so negative 3 and positive 3 cancel. Negative 3x and positive 3x. Negative 3x squared and positive 3x squared. So now I have the limit as h approaches 0 of, and you're going to write down what you have left. 6xh plus 3h squared plus 3h all over h. All right, so can I plug in, I don't know why that happens. Can I plug in 0 for h right now? Nope, because I'm still getting undefined. So now I say, okay, well, I'm going to use the cancellation technique. I need to factor my numerator. Now I realize the whole point of doing this is because you need the h to cancel. So the only thing you're going to factor out of the numerator is the actual h. I'm going to do that right to the right of this. So I have the limit as h approaches 0. Yes, you need that every single time. Factor out the h, so I have 6x plus 3h plus 3 all over h. Now the h's cancel out. Now I have the limit as h approaches 0 of 6x plus 3h plus 3. Now can I plug in 0 for h? Yes, because I don't get undefined anymore. Okay, so now I'm going to plug in 0 for h. So if I plug in 0 for h, I have 6x plus 3 times 0 plus 3. And I just have to simplify that. And I end up getting g prime of x. The derivative is, this is just 0 here, so 6x plus 3. And there's my final answer. Okay, so let's go back and do the first one. The first one's actually easier, but I skipped it because you'll see why. Okay, so we're going to find f prime of x. We're going to find the derivative of f of x. So we're going to do the limit as h approaches 0 of, all right, so I need f of x plus h, and I need to put that in brackets, remember. So I'm plugging in x plus h here. So I have negative 4 times x plus h minus 2, and I'll put that in brackets so I don't lose it. Minus, and then in brackets I need f of x. F of x is just this right here. Negative 4x minus 2 all over h. Can't plug in h yet, so I'm still going to write limit as h approaches 0. And now I'm going to distribute that negative 4. So negative 4x minus 4h minus 2. Distribute the negative here. Plus 4x plus 2 all over h. Simplify your numerator. I apologize for my freezing here. Simplify your numerator. Remember everything, where'd it go? Everything that was in this parentheses should cancel. So a 2 and a negative 2, a 4x and a negative 4x. So now I have the limit as h approaches 0 of negative 4h over h. Still can't plug in 0 yet for h, but I can simplify the numerator. If I factor out the h, I just get h times negative 4, and the h's cancel. So now I have the limit as h approaches 0 of -4. So now I can plug in 0 for h, which there is no h, so I get an automatic output of -4. That's why I didn't want to start with this one, because people were like, wait, what happened? Where did you plug it in? All right, so the derivative is -4. Okay, remember what the derivative is. It is instantaneous rate of change. It is the slope, okay? So what you're asking is you're finding the slope at any point. If you think about this, this is a line and the slope is -4. The slope is -4 everywhere. So I knew that before I even started, right? But I didn't know it here because this is not a line. 3x squared plus 3x plus 3 is not a line, so I don't know it, right? But people will always say like, well, can we just put down -4 as an answer? No, because it says use the limit definition of the derivative. It doesn't say use your knowledge of slope to find the slope. Okay. Next one right here, number 3. So we have f prime of x, which is the derivative of f of x. And then the limit as h approaches 0 of, okay, first thing I'm going to find is f of x plus h. So I'm plugging in x plus h there. 1 over x plus h plus 2 minus f of x, 1 over x plus 2 all over h. Okay, so now I need to clean this up. All right, so first thing I'm going to clean up is this numerator here, and I'm trying to zoom in so that you're just looking at just this numerator right here. Okay, I need to subtract those two fractions. In order to subtract two fractions, I need a common denominator, which I don't have right now. So my common denominator is going to be x plus h plus 2 times x plus 2. In other words, this times this. So I still need to multiply this by x plus 2 over x plus 2. And I need to multiply this by x plus h plus 2 over x plus h plus 2. Okay, so now I'm going to distribute this 1. So that's x plus 2. Limit as h approaches 0. I have x plus 2. And then this negative one I'm going to distribute. So minus x minus h minus 2. Minus x minus h minus 2 all over x plus 2 times x plus h plus 2 all over h. Okay, so now, and that was just really tricky algebra 1. If I lost you, look back at it, rewind, see what I did. Okay, so same thing here. -2 and +2 cancel. Negative x and positive x cancel. So now I have the limit as h approaches 0 of, I have negative h divided by x plus 2 times x plus h plus 2. And then it's divided by h again. So instead of making this a complex fraction, remember that's the same thing as divided by h, which is the same thing as multiplied by the reciprocal of h, which is 1 over h, right? So that's writing it like that's just going to make it easier, because then I can say h over h cancels, and I have the limit as h approaches 0 of, this is -1 times 1, which is -1, over x plus 2 times x plus h plus 2. And now I can plug in 0 for h. I couldn't in this step, because if I plugged in 0 right here, I get undefined. I'm not going to get undefined here. So if I plug in 0 for x, I get the derivative, f of f prime of x is -1 over x plus 2 times, and if I plug in 0 right here, I get x plus 2 also. So you can write x plus 2, or you can write x plus 2 quantity squared. Okay, so the last two are just their you-try practices. So you can go ahead and try number 1 here and see what you get as an answer. You should get 3 is the slope, and obviously it's because it's a line, but you need to show all your work for that. Okay, the second one here, I would go ahead and practice that also, but I'm going to also do it just so that in case you made a mistake, you can go back and check to see what you did wrong. Now, if you tried it on your own and you got that the derivative is negative 2x, you did it correct. Okay, so if you got the instantaneous rate of change is negative 2x, you can go ahead and stop, go get started on the homework. If not, let's watch me do it really quickly so that you can see where you made your mistake. All right, so f prime of x is equal to, oops, I almost forgot limit. Limit as h approaches 0 of, all right, I need f of x plus h, so I'm going to plug in x plus h here. Put my bracket down already. 1 minus x plus h quantity squared minus f of x, 1 minus x squared, all over h. Okay, equals, can I move to the side here? All right, so this expanded, remember, is limit as h approaches 0. I don't think that's enough room there. I don't like it. Okay, I'll just go below. Okay, so I got the limit as h approaches 0 of, then I have 1 minus, and then this, remember, is x squared plus 2xh plus h squared, and then distribute your negative here. So minus 1 plus x squared all over h. All right, I need to subtract this whole thing right here, so you do have to distribute your negative. I'm going to distribute my negative right above it so that I don't have to make an extra step. Because if I make an extra step, I have to write limit as h approaches 0 when I do that again. Okay, so right above it I'm going to do minus x squared minus 2xh minus h squared. And then cross this out, because I just distribute the negative there. Okay, so now we can see what cancels. X squared, negative x squared. Negative 1, positive 1. So now I have the limit as h approaches 0 of negative 2xh plus h squared all over h. All right, I can factor an h out of the numerator, so limit as h approaches 0 of h times negative 2x plus h all over h. H's cancel, and now I can plug in 0 for h. So you don't have to show where you plug in 0. You can just say f prime of x, or the derivative, is equal to, and if I plugged in 0 right here, I get negative 2x. Okay, go ahead and get started.